So simply by sending requests to every single possible IP by increasing the X value in here, we will be able to discover all of the valid clients or all of the live clients on the network. You can also change the Y value to discover the ports running on these clients. And we can do all of this using the intruder, which you've already seen how we can use. And once I do it now, you will see how simple it is and how similar it is to other uses of the intruder. The only difference is we're using it in a different example to achieve a different goal. So I'm going to right click this request and send it to the intruder. And in the intruder, as you know, first of all, we're going to clear the S signs so we can tell the intruder what to modify in each request that it sends. And what we want to modify is this number right here. So as we said, the X in here, in order to discover all of the computers that are connected to the same network as the server hosting the vulnerable application. So to do that, we're simply going to highlight the number 1 in here and click on add the S sign, and this way we're telling it that we're going to be modifying this value with every single request that you send. We're keeping the 8080 as is so that we're actually going to discover the devices in the same network that have port 8080 open. If you want to cover other ports, you would have to highlight this and add the S sign again, and then use the cluster bomb attack. We covered this before and you saw that it takes much longer. Therefore, I'm actually just going to keep it to modifying only one value in here. So we're keeping this as sniper, and we're just going to go to the payloads. We're going to keep the set to set 1 because we're using the sniper. And the cluster bomb, you would have to set different options for 1 and 2. But like I said, we covered that before, so there's no need to cover it now. For the payload type, we're actually just going to select numbers because, as you know, the IPs can only consist of numbers. And we're going to start from 1 and end at 254. As I mentioned, this is nothing that we are guessing. IP ranges start at 1 and end at 254. So we're simply just going with the default. And we're going to set the step to 1 so that we basically send a request to every single possible IP within the same range. If we don't get a valid response, that's fine. That means we don't have a device that is connected to the network that is running that port. If we do get a valid response, then we have discovered that device and we can go ahead and browse it. So as you can see, as a result, we're going to be sending 254 requests, and you want to make sure that you're actually URL encoding this request that is being sent in here. So Control U, and that's it. We're basically done. We're going to click on Start Attack. You want to leave this running for a while. As you can see, it sends a request to every single possible IP because that's what we configured it to do. And we can find the valid responses that indicate the existence of a valid running service by analyzing the status and the length. So you can see for number 1 in here, that's the one that we actually use to discover the vulnerability. You can see if we click on the response, we have the response saying missing parameter, and we can see straight away without even looking at the response, the status is 400, unlike everything else. Also, the length is different because the response had a different length. So you're going to have to go through all of the requests that were sent to the target and see the ones that have a different status than the normal one and a different length. Now, obviously, you can make that easier by simply clicking on the status in here, and it's going to order it based on the status. And as you can see, request number 167, which was sent to 192.168.0.167, gave us a 404 response. Now, a lot of us are familiar with that response, which basically means that the response is saying page not found. But like I said, this is still good. That means that there is a service running on the IP that is 192.168.0.167 on port 8080. Therefore, when we sent a request to this specific path, we got a response telling us that this page is not found. But that means that there is something running in there that sent that response. So it's very different to what we get everywhere else, where we simply just got a response telling us that we could not connect to the server. or even if it's giving you a less informative message. You can see that the responses in here are not useful at all, which indicate that there is nothing running on the IP that is being requested in the request in here. Whereas we have the 167 IP and the 1 IP, even though they're sending us errors, these errors are valid HTTP errors or valid errors in general that indicate that there was something running on the IP that was sent in the request on the specified IP and on the specified port. So all we have to do right now is simply send a request to a device that has this IP right here, and from there see what we can discover. So I'm going to right click this and send it to the repeater. And we're going to go to my repeater, make it bigger. And we know if we send this now, we're actually get something saying not found. As I said, we know that this IP is valid because it is responding to us. So you could go ahead and use the intruder and manipulate the value in here and discover other open ports, or try to send requests in here after this and see what you can discover, what paths you can discover, or what endpoints. Now, a very easy one that you could test is admin. And if we send it and render the response, you will notice that we managed to gain access to an admin control panel, and we have the users in here, Carlos and Wiener. And as I said earlier, you will be able to use this admin page and do everything that it allows you to do. As you can see, this is a simple one, but in a real life scenario, admin pages usually allow you to do so much more. Again, similar to what we seen earlier, if you wanted to use the functionality within this page, you're gonna have to right click whatever link that you want to run, copy the link address, and then send it as a forged request, exactly as shown in the previous lecture, because as we mentioned earlier, what we're doing right now is we are exploiting a server-side request forgery, and the target server, assuming it's server 1 in here, will not communicate with you directly. Therefore, even though we have the admin page loaded in front of us, we can't click on the links in there. We have to get the link that we want to run, create a forged request as shown in the previous lecture, and then get the vulnerable web application to get the server that is hosting it to send it on behalf of us. That way we're exploiting the trust that is established between this server, and therefore the request will actually be executed on the target.